Welcome to this short tutorial which is going to look at instancing lights to points in Houdini. And I've got a simple setup here. I've got a camera, I've got a plane, and I've got a series of spheres. And they're just to demonstrate how the lighting will affect the scene. So the first thing I need to do is emit some particles, and I'm going to do that from a circle. So let's lay down one of those, and I'm going to make the circle on the ZX plane. I'm going to give it a radius of 3, and I'm going to make it a polygonal circle with 6 points. And this is going to be what we're going to use to emit our particles. Well, the next thing I need to do is lay down a pop network, and I'm going to connect my circle to the first tab of the popnet, and then I'm going to lay down a source pop, and we're going to use the first context geometry, which is our circle, to emit our particles from, and points ordered is fine. And I'm going to birth just on the first frame, and I'm going to birth exactly one particle for each of the points in that circle. So if I put $NPT in here, that's what I get. And I'm going to turn off constant activation. Let's see what that does. Well, our particles are just staying where they are. That's because we're inheriting velocity, and there's no velocity attribute on the points of our circle. So we need to add one. Let's go up. I'm going to use a point swap to do this. Let's put the display flag on the popnet. There are two ways that we can do this. We could either add a normal to the points of our circle, or we can explicitly add a velocity attribute using the particle tab here. They both have the same effect. I'm going to use a normal because that's easier to visualize. So I'm going to add normals, and by default, as you can see, this produces some normals which simply point downwards, and that's not going to be what we want. What we want to do is spread the particles out away from the circle. But we can take advantage of the fact that this circle is centered on the origin, and if I change this to $TX, $TY, and $TZ, we can see that our normals are now pointing away from the center of the circle. And the reason for that is $TX, $TY, and $TZ are the position of the point that we're processing. So obviously if we take the vector from here to the point, that's going to point out away from the circle. And now we should see that our particles are indeed heading off away from the circle. Next step is to create a light that we can instance onto our points. And we can't unfortunately use one of the standard lights here, but we can use a light with an explicit shader. And the way to create one of those is to lay down a light template. And on the render tab of the light template, we can see that we can choose shaders for the light shader and the shadow shader. So we need to create some of those in a shop context. If I press the tab key, I get here some choices of mantra lights. We're going to go for a point light, and I'm also going to lay down a light shadow shader, the Vex shadow shader. So if we go back to our light template, I'm now going to select the point light as the light shader and the ray shadow as the shadow shader. Let's have a look at the point light. I'm going to set its color to black so that by default it's not going to show up. Now we need to instance this to our particles. But first of all, let's add some random color to the particles. So I'm going to append a color pop here, and I'm going to delete what's in there already and put rand $ID, and I'm going to reduce it a little bit because we don't want our light to be too bright. And then I'm going to copy this parameter, and I'm going to paste the copied expressions into the other components. But I need to offset these by some value, doesn't matter what, to ensure that we don't get the same color for each point, each component. Like so. So this should give some random color information on each of our points. The next thing I want to do is instance the lights. And the best way to do this is using a tool here on the Drive Particles tab, and it's here, the Instance tool. So the first thing we need to do, let me just make sure nothing is selected, select the tool. Then it invites us to select the particles. So let's do that. Let's press enter. And then we need to select the object that we're going to instance. So I'm going to select the light here in the network view, move my cursor over the 3D view and press enter. And we get this dialog box which says Object Circle Object 1 is not configured to render point instances. Would you like to configure it? And the answer to that is yes. So this has done two things, one of which is to add this instance node here in our pop network, which is ensuring that the light is instanced to each of our points. But it's also changed the node here, the geometry node, our circle object, by adding this instance tab here and adding this parameter point instancing and enabling it. And that's a necessary step for point instancing to work. Well, the next step is to ensure that our lights take on the different colors of our particles. And I need to do that here at the SOP level by adding a material SOP. And the attributes I want to add here are going to be point attributes. And I need to select the material, which is going to be the point light material, and I'm going to add one override for the local variable. And I need to put in here the light color. So let's have a look at our shop, and this is called light color and has three components, R, G and B. So if we go back here, we can add a color value and we can call it light color. Now the particles coming out of our popnet have a CD or color attribute defined, and we can in fact use the standard variables $CR, $CG and $CB to access those. So that should mean that we're getting a light color value overriding the default value of this. Let's check whether that's working here on the details view. We should find that we've got our instance parameter here, instance attribute. That's correct. And then we should have a material override here. And as we can see, we're getting the material override there. So let's have a look at a render view. And let's render this out. And what we should see, and there it is, that we're getting multicolored lights. Well, the next thing I want to do, just to finish this off, is to create some actual objects which are going to stand in the place of our lights. So let me lay down a geometry node, and let me call this light objects. And I'll switch to a scene view, and I need to dive inside our light objects and delete the file node. And what I'm going to do is object merge in our point data from the circle. So let's find that. So these will be our points which have the lights instance on them. And I'm going to transform it into this object. And we can see we've got 6 points. And let's choose a box. So I'm going to have a small box. Let's reduce its size. And I'm going to simply copy the box to each of these points, like so. And notice, by the way, that they get correctly orientated according to the normal. And I want to use the colour that we've used for the lights to colour these boxes. So the first thing I need to do is make sure that that's being passed across to the box. So I'm going to make sure that's got the right capitals. And if we have a look at the details view, we should see that the CD, or colour attribute, is now being passed to the points of our boxes. But those colours, if you remember, that we put on the points are multiplied by 0.1, so they're going to be a bit dark. So let me use a point swap to add colour, except what I'm going to do is take the existing colours and multiply them by 8. And $CG, for example, is the green component of the existing colour that's coming in, and then we're going to multiply each of them by 8. So we'll get a brighter version of those colours. And now I want to lay down a constant shader for use with these boxes. So let's go back to our object and choose the constant shader. And as you can see, this has now picked up the random colours that were assigned to the particles. Well, let's have a look what that looks like when we render. Well, that's interesting. What's happened is that the box is entirely enclosing our point light, and therefore the rest of the scene is in shadow. So we need to ensure that these boxes don't cast shadows. We can do that here on the light, and we can use this to ensure that the spheres and the grid cast shadows, but other things don't. In fact, we don't even need the grid to cast shadows, we just need the spheres to cast shadows. And now we should see that our boxes do indeed illuminate the scene. Well, there are a couple of minor tweaks that can be made to improve this. One of which is to go into our light objects here and append a trail SOP and change it so that it is computing velocity. And then here on the object itself, under the Render Sampling tab, we enable Geometry Velocity Blur. And then on our Mantra node, under Properties, Sampling, we allow Motion Blur. That will ensure that our lights are motion blurred as they move. And if we were to change the output of this to a file and render a frame range, we get the scene that we saw at the beginning. I hope that's been a useful introduction to instancing, and in particular instancing lights to points.